Hello there and welcome back on our continued discussion of using partial fractions to help us integrate. Now, partial fractions are really useful, especially when we get a little bit more complex integrals, for example, like number 1 right here. So, the hint that we're going to tell you, when can you use partial fractions? And here's basically the whole idea when you can use partial fractions. If you can factor the bottom. That's it. If you can factor the bottom. Don't worry about the top, just the bottom. So if I take a look at this example right here, I know I can factor the bottom. This becomes x plus 5, x minus 2. So I can rewrite this as I can write this using partial fractions. So this is the only complex part of the entire lesson for today, is the pre-calc. The calculus is pretty easy. We have to write this as a sum of two different fractions. So we have to decompose the fraction. So to do that, we're going to use our algebra skills that we learned last year in pre-calc. Equals, remember, each factor gets a fraction. So each denominator factor gets a fraction. So the first one is this x plus 5. Here we have x minus 2. Now, because these are both linear factors, the degree on top has to be 0. So they're just going to be numbers. We're going to talk later on what happens if it's not a linear factor. What do we do to the top? We'll talk about that later on in another video. So we're going to our two tops are A and B. We don't know what they are. Remember, we're trying to find out what do we need to put up here for A, what do we need to put up here for B to make sure that these two fractions add up to this fraction right here. So let's see here. Now notice again, they all have to be proper fractions. In other words, the degree on bottom has to be bigger than the degree on top. So we're checked with that. So we're going to multiply it by that LCD, that world famous LCD, which is just x plus 5, x minus 2. We know what this is because we made it. So we created that. So I'll multiply everything by the common denominator, and that's going to give me 4x plus 41 equals A. This becomes x minus 2 plus B, x plus 5. And now we're going to apply the heavy side method for finding A and B. So remember, these are our partial fractions right here. And now we're going to use the heavy side to solve this. And the heavy side says you're going to pick two x values. Right there. Now you can pick any two x values will work. But we're going to pick the zeros. And as we talked, we're going to pick the zeros because it makes it a little easier to solve. If one of these just goes away, it's easy to solve for B. So my first 0 is x equals 2. If we let x be 2, be careful, this becomes 8 plus 41, which is 49, equal to 0a plus 7b. So we got b is, what's that going to become? Oh, 7. So we got b already. My next 0 is x equals negative 5. Plugging negative 5 in, we get negative 20 plus 41. And that becomes positive 21. Equals, this becomes negative 7a, because negative 5 minus 2, negative 7a, plus 0b. So we know a is negative 3. That's the hardest part. Just remember this from pre-calc. So our next step, now we're going to rewrite our partial fractions. I'm going to put that over here, okay? So a, which we said was negative 3, so my new integral will be negative 3 over x plus 5 plus b, which is 7 over x minus 2 dx. Now we are going to be using u substitution, so we're going to do this a little bit quicker. Remember, my u is x plus 5, my du is dx. We like that. Here, u is x minus 2, du is just dx. We like that. You always want to check this just to make sure you're not dividing by anything. So our final answer, we're going to get negative 3. Remember, this is 1 over u. That's our u here. So we get natural log of u, which is x plus 5 plus 7 natural log x minus 2. Because remember, that becomes 7 over u plus c1. So you can leave your answer like this, that's fine. Or you can simplify a little bit. You can write these as a single log, but because of 3 and the 7 there, it's not as nice as some of the other ones that we can work with. Very easy to do. Note they don't take too long. The hardest part you're going to have is just the algebra, especially when we get to a problem like number 2 here. So let's take a look at this example. This is a little bit different. Note, in this case, in the denominator, which is already factored for us, yes. Note, we have 3 factors here. Therefore, we need 3 fractions. The number of factors determine the number of fractions. But there's a danger. Each power also gets a fraction. So we have to deal with this, okay? So if I want to decompose this, this is from last year. If we're going to decompose this, we get this 5x squared plus 20x plus 6 over x times x plus 1 squared. When I write this out, each factor gets a fraction. There's 3 of them. Now they've already factored it for us, so that's nice. So my first factor is x. My second factor, be very careful, even though it's the x plus 1 squared, my second factor is x just x plus 1. Now here's where it gets tricky. Each power also gets a fraction. So that's my x plus 1 to the first. But I also have to do the x plus 1 squared. And that's a little tricky. So you can go to one of my other videos and I discuss where this comes from right here. So, but for right now, we just got to remember, each factor gets a fraction. Each power gets its own fraction as well. So this x plus 1 is one of my factors, and I also have that x plus 1 squared. All right. Now we have to decide what goes on top. Well, this is a single degree, so on top I'm going to get just a number, a. In the next example, we're going to take a look at what happens if it's not just a. Here's a linear factor, so this becomes just b. It's really bx to the 0. We just don't ever write that. See, the degree is 1, the degree would be 0 up here. Same thing here. Even though it looks quadratic, that is actually just a linear factor squared. So there's still only a degree of 1 on the inside. That's all we really care about. So this is still a degree of 1. This is still a linear factor. So it has a degree of 1. So on the, there's a degree of 1. So on the top, we're just going to put c, x to the 0. You'll see the difference later on in another example when that is not just c. Alright, so now we're going to multiply by the LCD. So hopefully you kind of got the idea. The LCD is just basically that. So when I multiply by the LCD, we get 5x squared plus 20x plus 6 equals a. Now the a already has the x. It's just going to be multiplied by the x plus 1 squared. The b, it needs the x, but it also needs an additional x plus 1. The c has the x plus 1 squared. It's just missing its x. So sad. It's just missing its x. Alright, so there we go. Now we're going to pick variables. Remember, the Heaviside method says to now what we're going to do is we're going to pick 3 x values. Okay, that makes it really tough because we need a, b, and c this time. So I could randomly just pick any 3 x values, or I can just start with my zeros. Well, my first 0 is negative 1. If we let x be negative 1, right here, this is going to become 5 minus 20 plus 6 equals 0a plus 0b minus c. Be very careful. And if you solve that, what do we get here? Negative 15 plus 6. So we get negative 9 equals negative c. So c is just 9. Very easy. Now my next 0 is, well, literally 0. So if I let x be 0, we're going to get 0 plus 6 equals, be careful, this becomes a plus 0b plus 0c. So a is just 6. Now notice, we picked 2 x values. So we need a third x value. But if you notice, there's no more zeros. And that's kind of a big thing for us. There's no more zeros. So what do we do? Well, if there's no more zeros, you get to randomly pick one. So to find, so we have A and we have C. So we are going to randomly pick any x value. So I'm going to pick x equals 1. Keep it simple. Don't be like, I'm going to pick pi. It'll work, but it's not going to work out very nice. So I'm going to let x equal 1. But not only am I going to let x equal 1, I'm also going to plug in my A and C. And I'm going to plug in A and C here. So let's go and do that. This now becomes 5 plus 20 plus 6 equals, I already know what A is. A is 6. This becomes 6 times, be very careful, 2 squared, because that becomes 1 plus 1, plus, ready? I don't know what B is, but I know what X is going to be. This becomes 1 times 2 plus C times 1. C is 9 times 1. And if you clean all of this up, what you're going to wind up with is B is negative 1. Right there. And now I can rewrite my integral. Man, that's the longest part. Now the easy part is, now I'm going to rewrite our integral up here. So there it is. So my new integral will be, whoops, let me use this blue, will be A, which we said was 6, 6 over x plus B, B, which we said was negative 1. I'm not doing so good, so I'm going to start over. A, which we said was 6 over x, plus B, which we said is negative 1, over x plus 1, plus C, which is 9 over x plus 1 squared dx. So now we can integrate this. This is going to be the hard one here. So let's see if we can do this real quickly. Ready? This is just easy. 6 natural log of x minus, ready? U is going to be x plus 1. My du is dx. That's good. So that just becomes minus 1 natural log of x plus 1 plus 9. And now we got to deal with this one. This one's a little bit harder to deal with, okay? This one's going to be a little bit harder. This is saying 9 over u squared, right? If I let u be x plus 1, my du would just be dx. This becomes 9u to the negative 2 du, which becomes, if I bring this down, this becomes negative 9 over u. So that's what I'm going to use, plus c1. So this becomes a minus, so I scratch that out, make that a minus 9 over u, which I'm saying u is x plus 1 plus c1 right there. And there is our integral. Alright, hope you enjoyed this video. Go on to the next video, and we'll take a look at the hardest one you'll ever see. Okay? But before we leave, though, remember, the hardest part is just really the decomposition. The calculus doesn't take that long. I'll see you then. See you soon. Bye.